Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 1, Motion in One Dimension. We will be discussing the concepts and solve some examples. Are you ready for the session? Let's start. Let us start with motion. You wake up in the morning, you get dressed, you wear your uniform, you have breakfast and go to school. This is a daily routine. So when you go to school, some people will be walking to school, some will go in a cycle, some will go with their fathers in motorbike and some will be going the school bus. So once you get into the school bus, you will be seeing many objects. Inside the school bus, you will be seeing your friends, you will have the driver, then you will be having your teachers in the school bus. Also, when you look out through the window, you will be able to see many other things. You will see birds flying in the sky. You can see the sky. You will see the roads. Empty roads will be there. Some roads will be with traffic jam. You will see other vehicles. Some vehicles will be moving and some stationary shops will be there. There will be hospitals, there will be churches, many things you will be able to see, right? So when you just look at this, you will understand that some objects are moving and some objects are not moving. Once you reach school, you get into your classroom, you will see your friends there, you will see bench, you will see desk, teacher's table will be there, you will have the duster, chalk piece, many other objects you will be able to see inside the school. Okay, so here when you just look at these objects or just when you look around, you will be seeing that some objects are moving and some objects are not moving. So here we have some objects which you see regularly when you go from your home to school. Okay, here we have an empty road, then there is a car moving, you have forest, a bird is flying, you have your school bus, you have some benches and desks. Now tell me, which are the objects that are moving and which are not? Let's take the first one, your home. Is it moving? Home is not moving, right? Not moving. Next, what about this road? Is this road moving? Vehicles on the road can move, but the road will not move. So this is also not moving. What about the bird that is flying? Bird is flying. Flying is a type of motion. So here the bird is moving. Okay. What about the school bus? School bus is moving. You are inside the school bus and the school bus moving. Your school, does your school move? No, not moving. Inside your classroom, you have some benches and desks. Are they moving? Not moving. What about this car? The car which you found when you were in the school bus, which is moving in the opposite direction. Okay, is it moving? Yes, this is also moving. So here we have some examples for objects that are moving and some objects which are not moving. If an object is moving, we say that the object is in motion. And if there is no movement, we call it to be at rest. Okay, with respect to time, we know the time will anyway change. Time will never stop. When you look at your watch, you will be seeing that the time will be changing even though you are standing still or you are sleeping on your bed. The time will be changing, right? So with respect to time, if an object moves, the body is said to be at motion. And with respect to time, there is no movement for the body, then it is said to be at rest. If I am sitting here, okay, for 10 minutes, I am sitting here, am I moving or am I at rest? I will be at rest, okay. If I am walking in this classroom, then I will be in motion. The next 10 minutes, if I am sitting still, again I am said to be at rest. Okay, a body which was at rest can be brought into motion and a body in motion can go to rest with respect to time. So here we can define a body is in motion. A body is said to be in motion if its position is changing with respect to time and its surrounding. Okay, a body is said to be at rest if its position is not changing with respect to time and its surrounding. Clear? Got the idea what motion is and what rest is? Now look at this figure. Here we have a boy. Let us name him as X. Okay. So X is at a distance from his home and from his school. So he is on his path from home to school. Okay. Let us say that he is at a distance of 500 meters from his home and he is at a distance of 1 kilometer from the school. Okay. Now we are telling the position of this boy. Okay, with respect to home and with respect to school. From home, he is at a distance of 500 meter and from school, he is at a distance of 1 kilometer. Yes, with respect to something we are saying. So, this body is called a reference body with respect to which a body is measured. So, a distance or the position of a body is measured with respect to an other body. Okay, this body with respect to which the measurement is done is called the reference body. Here, home is a reference body and school is also a reference body. Now, what about the position? Position means it is a point where the body is. Okay, the body which is moving. So, here initially let's say X was at this position. Okay, so we will say that X is at a distance of 200 meter from his home and 1300 meter from his school. Okay, now he changes his position, reaches here. Okay, he is at a distance of 500 meter from his home and 1 kilometer from the school. He reaches here. Okay, this is the new position of X. Then we say that he is at a distance of 1200 meter from his home and 300 meter from school. So, with respect to school and home, we are saying. Okay, so this is his position. Now, take another example. Let's say that a boy is sitting inside a train. Okay, and you can find a boy outside. So, we say that when this boy looks into the train, he will be seeing the other boy who is moving. Yes, now just imagine a person who is sitting just opposite to this boy inside the train. Does he feel that the boy is moving? No, right? With respect to him, the boy inside the train is moving. With respect to the person who is sitting inside the train, the boy is not moving. Okay, so here everything depends on some reference point. Okay, clear? So, here we have the reference body. We understood what the position is of. So, we can define position. The location of an object with respect to a particular point is known as the position of the object. Here, the object is a boy and the reference body or with respect to what the measurement is done is here the home and the school. Now, what is reference point? The particular point about which the position of the object is defined is called reference point or origin. So, here let's say home is the origin. If home is the origin, his distance from the home, that is 500 meter. This is the distance for his from the home, and with respect to this origin, he is at 500 meter and this 500 meter will show his position. Okay. So, we can say if you have a straight road, okay, and your mother is asking where you have reached. So, here we have the home, okay, this is your home and where you have reached. How do we say? After some 2 minutes, you will be at 200 meter. So, my distance is 200 meter from home, okay. After 3 minutes, let's say 300 meter. So, distance from home is now 300 meter. Understood what this reference point idea is? Here the reference point or the origin is home. Let us recall what are scalars and vectors. So, here we have X is standing here and his teacher is asking him to move a distance of 50 meter. Okay, in which direction will he move? To east, west, north or south? He will have a confusion, right? If I am standing here and somebody is asking me to move 2 feet, to which direction will I move? I will have a confusion. Now, if somebody asks him what is his mass or what is the temperature inside the room? Will he have any confusion? Does it depend on the direction? No, right? If he just check the temperature to the right or to the left, he will be getting the same value. Even his mass will be the same. Yes, it doesn't depend on the direction. So, here you need to understand a quantity which depends on direction and the magnitude. Magnitude is this 250 meter. This is a magnitude. Direction and magnitude is called a vector quantity, and if it depends only on the magnitude, then it is a scalar quantity. When we said about temperature, let's say inside the room the temperature is 27 degrees Celsius. It doesn't depend on the direction. Okay, now the boy is asked to move 50 meter towards east. Okay, here east is the direction and 50 meter is the magnitude. So, it depends on magnitude and the direction. So, these quantities are called the vector quantities. Okay, so scalar quantity, it is a physical quantity. Physical quantity means something that can be measured. Physical quantities which can be expressed only by their magnitude are called scalar quantity. Example, mass. Then time. Time also does not depend on the direction. Temperature, as we said. Then distance, speed, etc. What about vector quantity? The physical quantity or measurable quantities which require magnitude as well as direction, which depends on both magnitude and direction in this case. Okay, so these are called vector quantities. Example, weight, displacement, velocity, etc. Let us understand what distance and displacement is. Again, we'll take the example. Here we have X. X is going to school from his home. Okay, here he can go in two ways. The first way is passing through the church and the library. Okay, second path is passing a hospital. So let's take the first path. Okay, here let's say that from home to church the distance is 300 meter. Okay, from church to library the distance is 500 meters, and from library to school the distance is 200 meter. Okay, so X, he starts from his home, first reaches the church traveling a distance of 300 meter, then reaches a library traveling a distance of 500 meter, and then reaches a school traveling a distance of 200 meters. Okay, this total distance he travels, that is, when you take the length of path followed by him is called the distance. When you add, you will be getting 300 meters plus 500 meters plus 200 meters. So, for the boy, for X to reach from home to school, he travels a total of 1000 meters or 1 kilometers. This 1 kilometer, the length of path followed by him is called the distance. Okay, this is the total distance that he travelled to reach school from home to school. Okay, now after class in the evening, what is doing? He is going from school to home. Now he plans to go through the second path, that is, he first reaches the hospital. Okay, let's say hospital is at a distance of 600 meters. Then from hospital he can go to his home. Okay, this is the second path. And from hospital to home the distance is, let's say, 300 meters. Okay, so 600 plus 300 is the distance that he's travelled in the evening. So here we get 900 meters. So from school to home, he travels a distance of 900 meters. Okay, now what is the total distance he travelled or total length of the path? That is, he started from home and reached back home. Yes. So, from home to church, church to library, library to school, school to hospital, and hospital to home. So, what is the total distance that he travelled? Total distance or total length of the path. Let's represent it by D is equal to adding all these 300 plus 500 plus 200 plus 600 plus 300. Okay, you will be getting 1900 meters or 1 kilometer 900 meter. So, this total length of the path he followed is giving you the distance. Now, what is displacement? To understand displacement, it is the straight line distance or the shortest distance from the initial position to the final position. So, here initially the boy is at his home and final position. So, once he reaches the school. Okay, if we are taking from home to school as reference, from home to school, the straight line distance, this straight line distance is called displacement. Okay, from home to school. Let's say this is 700 meters. Okay, from home to school, displacement is equal to is equal to 700 meters when you consider it from home to school. So, what about from school to home? School to home, he is travelling through another path, that is, he is passing the hospital. But doesn't matter, the straight line distance will be the same. It will be 700 meter. The straight line distance will be the shortest distance from school to home and home to school. So if you are taking from home to school, then this straight line distance 700 meter is the displacement. If you are taking the complete journey, that is his total journey, starting from home, church, library, school, hospital, home. Okay, he has reached his home. That is, initial point is home and final point is also home. In that case, what will be the displacement? Here you can see the initial and final positions are same. So you will be having a displacement equal to 0. Okay, displacement will be 0. Will be 0. That is home to home. Starting from home, final position is also home. Got it? So distance, it is the actual length of the path travelled by a moving object, and displacement, it is the shortest distance or the straight line distance between the initial and final position of the object. Okay, here now tell me, you have studied what are scalar quantities and vector quantities. Which of them is a vector quantity? We know that vector quantity depends on magnitude and direction, whereas scalar is only magnitude. So here when you take the case of distance, it doesn't depend on direction. Okay, so it is a scalar quantity. Okay, what about displacement? It depends in the direction. Yes, in which direction is moving, it is dependent. So it is a vector quantity. Next, what is the unit? Here it is a length. Okay, length. Unit of length is meter. So meter is the SI unit. You have other units like kilometers, centimeters, millimeters, etc. So distance and displacement usually we will be measuring it in meters. Now take this case. Here we have the boy. He starts from a point A, reaches B, then reaches C, D and E. Okay, let's say A to B, the distance is 100 meter, B to C 100 meter, C to D 100 meter, D to E 100 meter. Okay, so here this is his first position or the initial position. So when he reaches B, what is the distance and displacement? Okay, A to B, the boy is traveling. What is his distance and displacement? Now tell me, A to B, 100 meter he has travelled. Okay, so the distance, length of path travelled is 100 meter. So this is the distance. What about displacement? Shortest distance between A and B is also 100 meters. So the displacement will be 100 meters. Okay. Now from B to C, he travels from B to C. So here you can see from A to C, total distance he travelled will be equal to 200 meter. And the shortest distance will also be equal to 200 meter. So from A to C when considered, distance will be 200 meter. And the displacement will also be 200 meters. Next, from A to D, to reach the point D, when you consider 100 plus 100 plus 100, 300 meter. 300 meter will be the distance. What about displacement? The shortest distance is also the same. So again 300 meters. Okay. Next, A to E. What about A to E? 100 plus 100 plus 100 plus 100, which is 400. 400 meter will be the distance and the displacement will also be equal to 400 meter. Okay, now take his return journey. That is, he has reached E and from E he comes to D. Okay, then what is the total distance? What is the total distance? 100 plus 100 plus 100 plus 100 plus again 100. From D to E, 100. From E to D, reverse, again 100, which means 500 will be the one that we get. So here, during the return journey, you will be getting 500 meter to be the distance. What about displacement? Shortest distance from A to D, the shortest distance is 100 plus 100 plus 100. This is the straight line distance. We don't need to consider this part. Okay, we just need to consider the initial and final positions. Okay, so the shortest distance will be equal to 300 meter. 300 meters. So here we are taking the reverse journey. First reaching from A to E, then moving to E to D. Okay, next from A to E, from there E to C. E to C. what happens? Distance. We'll have to add this 100 meters again. Then we get 600 meters. What about displacement? Shortest distance or the straight line distance? That will be equal to 100 plus 100, which is just 200 meters. 200 meters. Okay. Then A to E. First reaching E, then from E to B. E to B. What will be the total distance? Distance will be equal to, again adding 100, that becomes 700 meters. And the displacement, shortest distance from A to B is 100 meters. Okay. Then the final position, that is he reaches back to A. Then what is the distance? Total 100 plus 100 plus 100 plus 100, reverse again 100, 100, 100, 100. On adding you will be getting a total of 800. A to E, E to A. 800 meters, and the displacement will be here 0 because initial and final positions are same. So what do you understand from this? You can see that distance is always having positive values. Yes, positive values, that is increasing. Also distance can be 0. If the body is not moving, the distance travelled will be 0. So distance can be 0 or positive values only. What about displacement? Displacement, here you can see that displacement is initially increasing, then it is decreasing, and finally it becomes 0. Okay, so we will be having 0, we can have positive values, we can also have displacement to get negative values. Negative displacement is also possible. Okay, so let us differentiate between distance and displacement. This is very important, this comparison and the difference. So distance and displacement. What is distance? First you will be writing the definition. It is the actual length of the path travelled by a moving object irrespective of its direction of motion. What about displacement? It is the shortest distance between the initial and final position of the object in a given direction. Direction is important. One is a scalar quantity. Distance is a scalar quantity and displacement is a vector quantity. It depends on the path. We have said in the first case, starting from home to church, church to library, library to school. So what about displacement? It doesn't depend on whether the boy has passed through the church and then through the library or he has taken the other path. It is only dependent on the initial and final position. Therefore, it does not depend on the path. Distance is always positive or it should be 0. Displacement can be positive, negative or 0. Clear? Let us now take an example. A jogger jogs along one length and breadth of a rectangular park. If the dimensions of park are 150 meter by 120 meter, then find the distance travelled and displacement of the jogger. So here you have a rectangular path A, B, C, D. It is given that the jogger jogs one length and breadth of a rectangular path, which means once along the length and once along the breadth. And the dimensions are also given. Length is 150 meter and the breadth is 120 meter. Now, what is the total distance travelled? We have said that distance depends on the path followed and displacement does not depend on the path followed. So, first let us find the distance travelled. Distance travelled is equal to, first he starts from A, reaches B. What is the distance? It is 150 meter. 150 meter plus from B he reaches C. C is his final position. Okay. First along the length and second along the breadth. So, this is 120 meter. 120 meter will be equal to 270 meters. So, the total distance travelled by the jogger is equal to 270 meters. Next, we will find the displacement. Displacement is the shortest distance or the straight line distance from the initial and final position. So, this is the initial position and this is the final position. So, we will draw a straight line connecting the initial and final positions. So, this distance will be giving us the displacement. Now, how to find this distance? Here you have a right triangle. For a right triangle, hypotenuse square is equal to base square plus height square, Pythagoras theorem. Okay. Therefore, AC is the displacement. AC square is equal to AB square plus BC square. AC is equal to root of AB square plus BC square equal to root of AB square, which is 150 whole square plus BC square 120 whole square. Okay, that is equal to 15 square we know, that is 225 and 2 zeros plus 120 square, 12 square we know, 144 and 2 zeros. So when you add them and take the root, you will be getting a value 30 root 41 meters. So here the displacement is 30 root 41 meters and the total distance travelled is 270 meters. Clear? Second example, a body moves in a circular path of radius 20 centimeter. If it completes 2.5 revolution along the circular path, then find distance and displacement of the body. So here we have a circular path. Let's mark 2 points A, B of radius 20 centimeter. Okay, the body starts from A, reaches B, B to A. So here it is given 2.5 revolution. 2.5 revolution means starting from here, one complete revolution, second complete revolution, and half means from A to B. This is half. Okay, so here you will be having. Now what is the total distance travelled? So here in case of a circle, how can you find if a boy is moving along the circle a complete round? Then how to find the total distance travelled? The total distance travelled will be the circumference of circle. How to find the circumference of circle when radius is not? We have a formula 2 pi r. Okay, so here the total distance travelled is equal to. Now remember, here we have 2 complete revolutions. 2 pi r is the total distance travelled when it is a single revolution. For 2 revolution, it will be 2 into 2 pi r plus 2.5 revolution. What about half revolution? If this complete distance is 2 pi r, for half it will be pi r. Okay, pi r, that is equal to 4 pi r plus pi r, which is 5 pi r. What is the value of pi? 5 into pi is 3.14 and radius is given 20 centimeter. Okay, that is equal to 5 into 20 is 100 into 3.14, which is 314 centimeters. So the total distance travelled is 314 centimeter. Now we can find the displacement. How to find displacement? What is displacement? Displacement should be the shortest or the straight line distance. So initially he started from here, one complete revolution he reaches A. Second revolution also he reaches A. Next the half revolution he will be reaching the point B. So from A to B the straight line distance. What will be the straight line distance? From A to B, this distance will be the diameter of circle. We know radius, diameter will be 2 times radius. Okay, therefore displacement is equal to 2 into 20 centimeter, which is 40 centimeter. So we have determined both the distance and displacement. Understood? Now let us understand what is speed and velocity. For that we will take the same example. So here we know the distances. This is 300 meter, this is 500 meter and this is 200 meter. Reverse. Here we have 600 meters and this is 300 meters. From here to here the straight line distance is equal to 700 meters. So what is speed? How to find the speed? We have a speedometer. In case of vehicles you will be seeing a speedometer in which the variation of speed can be seen. So here let's say from home to church the boy takes a time of 3 minutes to travel a distance of 300 meters. From church to library he takes 5 minutes to travel a distance of 500 meters. Okay, from the library to school he takes 2 minutes to travel a distance of 200 meters. So what is his total distance travelled? Total distance we know, total distance is equal to 1000 meters. What is the total time taken? Total time taken is equal to 3 minutes plus 5 minutes plus 2 minutes. To start from his home and reach the school he has taken 3 plus 5 plus 2, which is 10 minutes. Okay, to find speed, what you have to do is, you have to take the ratio of distance and time. That is, speed is equal to, speed is distance divided by time, or the total distance travelled by total time taken. In this case, 1000 meters divided by 10 minutes. Okay, now we have to remember one important point. When you are taking length or distances in kilometers, then the time should be in hours. And if you are taking the distance or length in meters, then the time should be in seconds. So you have to convert this 10 minutes first to seconds. So what is 10 minutes in seconds? We know 1 minute is equal to 60 seconds. Therefore 10 minute will be equal to 10 into 60, which is 600 seconds. That is 1000 meter per 600 seconds. So cancelling out zeros, 10 divided by 6, you will be getting 1.666. It will go, so 1.667 meter per second. So the unit of speed is meter per second. Okay, 1.667 meter per second is the speed in which the boy is traveling. Okay, now let us take the reverse path. So from school to hospital, let's say he takes 6 minutes, and from hospital to home he takes 4 minutes. So here what is the total distance travelled? Total distance is equal to 600 plus 300, that is 900 meters, and the total time taken will be equal to 6 minutes plus 4 minutes, that is 10 minutes. Okay, 10 minutes. Now we can find the speed. Speed will be equal to distance by time, which is 900 divided by 10 into 60. Okay, cancelling the zeros. 9 divided by 6, you will be getting 1.5 meter per second. Okay, 1.5 meter per second is the speed in this case. Speed is equal to 1.5 meter per second. So you can understand that going from home to school, he is travelling at a speed of 1.667 meter per second, but from school to home, he is travelling at a speed, because he was tired and is just travelling at a speed of 1.5 meter per second. Okay. Now what about the other case? That is the case of displacement. We know displacement is the shortest distance between the initial and final position. Okay. Now when you take the speed, when you calculate the speed for the complete journey, that is starting from home, reaching the school, back to home. In that case, what is the total distance travelled? We know the total distance travelled in this case will be equal to, speed is distance by time, total distance travelled will be 1900 meters. Total time taken, here 3 plus 5, 8, 8 plus 2, 10, 10 plus 6 is equal to 16, 16 plus 4, 20. Okay, 20 into 60, converting to seconds. So when you calculate this, you will be getting 19 divided by 12 meter per second. So you can calculate and find what the speed is. Okay. When you take the case of displacement, displacement is the shortest distance we know. Using displacement, we will be calculating the velocity. So velocity, as we said, speed is equal to distance by time. Then the velocity is equal to displacement divided by time. Okay. So the first case, we know the displacement is equal to, when you take from home to school, the displacement is 700 meters. And the total time taken is equal to 10 minutes. Okay, so 700 divided by 10 into 60, which is 600. 7 by 6 will be 7 by 6. Again, the unit is meter per second, will be the velocity. Okay. Now, when you take the complete journey from home to school, back to home, we know the displacement is 0. Then what will be the velocity? Velocity will also be equal to 0. For the complete path when taken, velocity will be 0 divided by the time, which is 20 minutes. You will be getting 0 meter per second. Okay, for the complete journey, the velocity is 0 meter per second. Understood what speed is and what velocity is? So what is speed? Speed of an object is defined as the distance travelled by it per unit time, or rate of change of distance with respect to time is called speed. Okay, what about velocity? Is the displacement of a body per unit time, displacement divided by time. So we can say speed is equal to distance by time, and velocity is equal to rate of change of displacement, or displacement divided by time. Okay. Now the unit of both speed and velocity is meter per second. Another unit that is used is kilometer per hour. How to convert kilometer per hour to meter per second? Now you can see 1 kilometer per hour. What does it mean? It is 1 kilometer divided by 1 hour. Yes, 1 kilometer by 1 hour. What is 1 kilometers in meters? That is 1000 meters by 1 hour in seconds. 1 hour is 60 minutes and 1 minute is equal to 60 seconds, which means 1 hour will be 60 into 60 seconds. So 1000 meter divided by 60 into 60, 3600 seconds. So here cancelling out zeros, again cancelling, we get 5 and 18. So 1 kilometer per hour is equal to, if you are asked to convert kilometer per hour to meter per second, 1 kilometer per hour is equal to 5 by 18 meter per second. Okay. Now if I am taking this 5 by 18 to the opposite side, what happens? It will become the reciprocal. Okay. So here you will be having 1 meter per second, and here you will be having 18 by 5 kilometer per hour. If you are asked to convert meter per second to kilometer per hour, what you have to do? You have to multiply with 18 by 5. Okay. So if you have 2 kilometer per hour, if you are asked to convert this 2 kilometer per hour into meter per second, what is done? 2 into 5 by 18 meter per second. Cancelling, it becomes 9, that is 5 by 9 meter per second. Okay, if you are asked to convert 2 meter per seconds into kilometer per hour, it will be equal to 2 into 18 divided by 5 kilometer per hour, which is equal to 36 by 5 kilometer per hour. Now, here again, we have 5 different positions of X, A, B, C, D and E. As we said, A to B, the distance is 100 meter, B to C 100 meter, C to D 100 meters, D to E 100 meters. Let's say from A to B, to travel 100 meters, it takes a time of 50 seconds. From B to C, 50 seconds. From C to D, 50 seconds. And D to E, 50 seconds. Okay. So, we are calculating from A to E and back to C from E. Okay. First, he moves from A to E. Then from E to C. So, what is the total distance travelled? We are going to find the speed and velocity separately. So, from A to E and E to C. Back to C. Okay. So, what is the total distance travelled? Distance is equal to, total distance 100, 100, 100, 100 plus 100 plus 100. Okay. So, total you will be getting 600 meters. And what about the time taken? Time taken will be equal to 50 seconds, 50 seconds, 50 seconds, 50 seconds, 50 seconds, 50 seconds. Okay, 50 into 6, which is equal to 300 seconds. And the speed is equal to total distance by total time, 600 meter by 300 seconds. Cancelling, you will be getting 2 meter per second. So, 2 meter per second is the speed. Okay. Now, what about the velocity? To find velocity, we need the displacement. Here, what is the displacement? Shortest distance or the straight line distance from the initial and final position. A is his initial position and C is his final position. So 100 plus 100, which is equal to 200. Displacement is 200 meter. What about time taken? Time taken will be the same, which is equal to 300 seconds. Okay. Therefore, 2 by 3 meter per seconds is the displacement. Sorry, is the velocity. Okay. So we got speed and velocity. Speed and velocity are different. Now we take another case. Boy starts from A and he reaches E. Here what is the total distance traveled? We'll find from A to E the speed first. Total distance traveled is 100 plus 100 plus 100 plus 100, which is 400 meters, and total time taken 50, 50, 50, 50. 50 plus 50 plus 50 plus 50, which is 200 seconds. We will be getting 2 meter per second as the speed. The same thing we are getting. What about velocity? Here what is the displacement? In this case the displacement and the distance will be same because this is a straight line path. Along the straight line path, if it is moving, a body is moving in the same direction, distance and displacement will be same. Therefore, displacement will also be equal to 400 meters and time will be 200 seconds. Okay, we get 2 meter per second. So, distance and displacement are same, therefore, speed and velocity are same. Okay, here we are getting same value. Now, we will take another case. The third case is from A to E, E to A, back to A. So, here what is the total distance travelled? We will find the speed from A to E, E to A. Okay, speed will be equal to total distance travelled 100 plus 100 plus 100 plus 100, again 100 plus 100 plus 100 plus 100. Total we get 800. 800 meter. What about time? 50 plus 50 plus 50 plus 50, again 50 plus 50 plus 50 plus 50, which is 400 seconds. So, you will be again getting 2 meter per second as the speed. What about the velocity? Now, tell me what is the velocity? What will be the velocity? Here the initial point and the final point are same. Therefore, displacement becomes 0. When displacement is 0, 0 divided by time taken is 400. 0 by any number you will be getting 0. Yes. So, we have the velocity. What is happening? The velocity is changing. But the speed is same in this case. Okay. And also we are getting velocity value to be equal to 0. We will also get negative values of velocity. So, what are the differences between speed and velocity? Speed, first the definition, rate of change of distance, and velocity is the rate of change of displacement. Speed is a scalar quantity because it is not dependent on the direction. It does not depend on the path. Whereas velocity depends on the path, therefore it is a vector quantity. Okay, speed is distance by time and velocity is displacement by time. Speed is always positive, velocity can be positive, negative or 0. So, there are different types of speed. First, let us understand what is uniform speed. For that, you consider a case, a boy is moving in a car. His initial point will mark as A. From A, he reaches B. From B, he reaches C. C to D. D to E. And E to F. Let's say F is his final position. So, A to B, he travels a distance of 10 meter in 1 second. From B to C or from A to C, he travels a total of 20 meter. That is B to C, it is 10 meter. Again, he takes 1 second. So, total in 2 seconds, he is traveling 20 meters. Again, 10 meters in the next 1 second. 10 meters in 1 second. 10 meters in 1 second. Okay. So, then he reaches the point F. So, here from A to B, the distance travelled is 10 meters. From B to C, the distance is 10 meters. C to D, the distance is 10 meters. D to E, the distance is 10 meters. And from E to F also, the distance is 10 meters. What about the time taken? A to B, 1 second. B to C, 1 second. C to D, 1 second. D to E, 1 second. And E to F, 1 second. So, to move from A to B, What is the speed? Speed is distance by time. 10 meter by 1 second. You will be getting 10 meter per second. From B to C, again 10 meter per second. 10 meter by 1 second. Again 10 meter per second. From D to E, 10 meter per second. From E to F, 10 meter per second. So we'll have all the speeds same, which means the body is said to be in uniform speed. It is having uniform speed because the speed is always having the same value. The body or the boy in the car is moving. The car is moving at 10 meter per second. It is not changing. So we can define uniform speed as if a moving body covers equal distance in equal intervals of time, then the speed of the body is said to be uniform speed. So here equal distances travel 10 meter in 1 second. Next interval of time, again 1 second, 10 meters. Again 1 second in 10 meters. Again 1 second in 10 meters. So equal distances is travelled by the body in equal intervals of time. Then the speed is said to be uniform speed. Non-uniform speed. The boy starts. He starts from A. He reaches a point B. B to C. C to D. D to E. And E to F. F is his final position. So the first 1 second he travels a distance of 10 meter. That is from A to B he travels 10 meters in 1 second. Okay. From B to C now he travels just 5 meters in the next 1 second. Okay. B to C 5 meters in 1 second. Next C to D he travels 8 meters in 1 second. C to D, 8 meters in 1 second. D to E, he travels just 3 meters in 1 second. D to E, 3 meters in 1 second. And E to F, he travels 11 meters in the next 1 second. 11 meters in 1 second. Okay, here what are the speeds? So first from A to B, he is traveling at a speed of 10 meter per second. 10 meter by 1 second, which is 10 meter per second. B to C, he is traveling at a speed of 5 meter per second. C to D, 8 meter per second. D to E, 3 meter per second. And E to F, 11 meter per second. So these are his speeds. Okay. You can see that when you observe these values, you can see that they are different. In the previous case, all the speeds was equal to 10 meter per second. But here we have 10 meter per second, 5 meter per second, 8, 3 and 11 meter per second. So we have different speeds. Okay, what do we understand? In equal intervals of time, the distance travelled is different. Therefore, the speed is different. We call this speed as non-uniform speed. Okay. So we can define if a moving body covers unequal distance in equal interval of time, then the speed of the body is said to be non-uniform speed. So how do we get non-uniform speed? In equal interval of time, the distance travelled is unequal. Okay. Clear? Do you think maintaining a uniform speed is always easy? So when you are travelling in a car, you can see that at sometimes the speed increases, at sometimes speed decreases, at sometimes the body comes to rest. In all these cases, what is happening? The speed is changing. Okay. So in that cases, you need the average speed. You will be calculating the average speed. Let's see how. So here, the boy is travelling in his car, starting from A, reaches the point B. Let's say in 1 second, he travels 10 meters. Okay. B to C, he travels in 2 seconds a distance of 15 meters. Okay. C to D, he travels 8 meters in 3 seconds. Next, D to E, he travels 17 meters in 4 seconds. And from E to F, so before that what he does is, at E, 5 seconds, he is not travelling. That is, he is applying brakes and he is at rest. Okay. Then after this 5 seconds, again in the next 5 seconds, he will be travelling 5 meter distance in 5 seconds. So here I will be calculating the average speed. So remember, in this case, in each interval you can find the different speed. So here you can see that the intervals, time interval is also different and the distance travelled is also different. That is unequal distance and unequal intervals of time. Therefore, we will be taking the average speed. Okay, so you cannot find. So here the speed is 10 meter per second. Here the speed is 15 divided by 2, that is 7.5 meter per second. Here the speed is 8 divided by 3 meter per second. So average speed does not mean you will be taking the average of all these speeds. It is not like that. You will be taking the total distance travelled and total time taken separately and take the ratio of it to get the average speed. Therefore, average speed is equal to total distance travelled, adding all the distance, that is 10 meter plus 15 meter plus 8 meters plus 17 meters plus 5 meters whole divided by total time taken, adding starting 1 second, then 2 seconds, 3 seconds, 4 seconds, 5 seconds and again 5 seconds. So adding, what do you get? 10 plus 15, 25, 25 plus 8 is equal to 33, 33 plus 17 is 50, 50 plus 5, 55 meters. So 55 meters divided by total time taken, 1 plus 2, 3, 3 plus 3, 6 plus 4, 10, 10 plus 5, 15, 15 plus 5, 20. 20 seconds, which is equal to 5.5 by 2 meter per second, or that is equal to 2.75 meter per second. 2.75 meter per second, which is the average speed, and this is how you will be finding the average speed. Clear? Instantaneous speed. So we said, what is average speed? Instantaneous speed is nothing but the speed at a particular instant of time. Like we have said, the first 1 second is traveling at 10 meter per second. If you are taking any point, let's say the point B. At B, what is the speed? At that particular instant, the speed that is measured is called the instantaneous speed. Let's say it is equal to 8 meter per second. Or at a point C, it is 17 meter per second. Or at another point, it is 11 meter per second. So this instant, at a given point, at a particular instant of time, what is the speed? That speed which is measured is called the instantaneous speed. The speed of an object at any particular instant of time or at a particular point of its path is called the instantaneous speed. Got the 4 types of speed: uniform speed, non-uniform speed, instantaneous speed and the average speed. Let us take an example. Example 3, an object travels 14 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? How to find average speed? We have average speed is equal to sum of the distances. Let us say S1 is the first distance, S2 is the second, S3 is the third, plus etc. up to some Sn. Time taken, first time T1, then T2, then T3 plus etc. plus Tn. So the total distance travelled by total time taken gives the average speed. So here the total distance travelled. First we have 14 meters, then we have 16 meters. 14 meter plus 16 meters divided by 4 seconds is the first time and the second we have 2 seconds. So 14 meter plus 16 meters you will be getting 30 meters divided by 4 seconds plus 2 seconds, 6 seconds, which is equal to 5 meter per second. So the average speed which we can represent as V average is equal to 5 meter per second. Got it? So we have said about uniform speed and non-uniform speed. Now it is uniform velocity and non-uniform velocity. When it comes to the case of velocity, we will be considering displacement. So to get uniform velocity, you will consider the displacement. Okay, in equal intervals of time, what is the equal displacements? Then when it comes to the case of non-uniform velocity, there will be unequal displacements in equal intervals of time. Just this is the difference. So uniform velocity, if an object covers equal displacements in equal intervals of time without changing direction, then its velocity is known as uniform velocity. So when direction changes, it becomes non-uniform velocity. So because we know that velocity depends on both magnitude and direction. So if direction changes, there is some change happening. It is not just the magnitude that is not changing, it is remaining equal. The direction should also be the same. So non-uniform velocity, if an object covers unequal displacement. Displacement, it can be dependent on the magnitude or in the direction. Direction change can also happen in equal intervals of time, then its velocity is known as non-uniform velocity. Okay, so we have said about the average speed. To get the average speed, total distance divided by total time taken. Then what about average velocity? To get average velocity, total displacement divided by total time taken. If the body is in a uniform motion, that is in uniform motion case, in that case, if you know the initial and final velocities, you can find the average velocity. We have V average is equal to total displacement divided by total time. Okay, let's say initially the velocity of the body is taken as u, initial velocity, and the final velocity is v. Okay, u is the initial velocity and v is the final velocity. Okay, then what is the average velocity? To get average velocity, v average will be initial plus final divided by 2. Initial velocity plus final velocity divided by 2 will give you the average velocity. Let's say initially it is 10 meter per second and the final velocity is 20 meter per second. Now what is the average velocity? V average will be equal to 10 plus 20 divided by 2, which is 30 by 2 equal to 15 meter per second. Okay, 15 meter per second is the average velocity. Again, if you know different velocities, you cannot take the sum and divide it by the number of velocities known. So here you will have to take the total displacement and total time. Only in uniform case you can take the initial plus final divided by 2. Now what about instantaneous velocity? Instantaneous speed means the speed at a particular instant for at a particular point. So instantaneous velocity, the velocity of an object at any particular instant of time or at a particular point of its path is called instantaneous speed. Let's say at B, at the point B, starting from A at a point B, at this particular instant, at the point B, the velocity of the body is equal to 10 meter per second. This velocity is called the instantaneous velocity. On the speedometer, what it shows is the instantaneous velocity. At point C, if you are taking, at this point C, let's say the velocity is equal to 11 meter per second. Then this 11 meter per second is nothing but the instantaneous velocity. Okay. So initially the body is at rest. Okay, the boy has not started the car. Then at this particular instant, what is happening? The velocity will be equal to 0 meter per second. Okay, at the final point, let's say at D, what happens? He applies brakes and brings the car to rest. Again, the velocity at this particular instant, the velocity is equal to 0 meter per second. Okay, so this velocity is the instantaneous velocity. That's all for today. In today's class, we have discussed motion in one dimension. We have understood what distance, displacement, speed and velocity is. Different types of speeds and velocity we have discussed with examples and solved many questions. Hope you all enjoyed this session. I'll be back in the next session with the next part. Till then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.